practical.
Okay.
So be quiet and patient.
Okay.
Okay. Good advice.
So we will continue our discussion, which we started with specifically explaining science first. Then we started discussing physics,
Mechanics.
right? But when we are discussing physics,
we are discussing mechanics.
when we started discussing physics, specifically mechanics, then I thought to explain some of the key geometrical properties, laws to you, so that it makes more sense. Okay. Now in physics, what we discussed is something called physical quantity, right? Who can tell me what is a physical quantity?
A physical quantity. Wait,
A quantity.
A physical quantity. A physical quantity has dimensions.
Yeah, a physical quantity is basically a meaning given to a number. In a sense, you can say that any number with a specific unit becomes a physical quantity. Like there are things which you observe in this surrounding, the environment, in this universe, and you name them, right? You give some name to them, and that becomes a physical quantity, right? A physical quantity is something which you can calculate. Things you can't calculate is not a physical quantity. Can you calculate the degree of anger or the intensity of love?
No.
Or the level of cheekiness? No?
No.
So these are not physical quantities. It doesn't mean that these things don't exist. It exists, they have got their realities, but they are not physical quantity. Okay? So physical quantity, a quantity has got some magnitude and some unit to express what type of physical quantity it is, right? These units are also called its dimensions, right? So a physical quantity could be length,
kg.
right? So the dimension of length is referred as L, capital L, right? And its unit is what? Meter, right? Now physical quantity could be of two types. How many types?
Two types.
Why two types?
There are actually three types. There's actually three types.
Yeah, so depending on the origin of a physical quantity, it is only two types. One is called fundamental, another is called derived, right? So this is depending on the nature of physical quantity. But depending on the kind of laws they follow, they are of three types: scalar, vectors, and tensors, right? Now, fundamental physical quantities are those quantities for which are defined fundamentally, like they have its origin in itself.
Yeah,
Like-
you can see how long something is with a ruler.
Yeah,
You can measure
like
its
length,
weight,
mass, time, temperature, etc., right? So to measure length, you need something, right? You need some standard, and that standard gives you some unit, right? So you need a standard which says it is 1 meter. Is it possible that you have your own 1 meter and Mariam has got his own and your school friends have his own? Imagine if everyone is having their own definition of 1 meter. What's going to happen?
It's going to be a mess.
Yeah, so there are international organizations who define how much will be 1 meter, how much will be 1 kilo or 1 pound,
1 meter.
how much will be 1 second. right? It is all defined by some international organization, and that's why they are called fundamental physical quantities. But imagine a physical quantity like a speed, right? In India, if you go on road and see trucks, it's written something like this, 40, and there is a circle. I think it's near the school as well, that in school time you have to follow this 40. So what is this 40? It is actually 40 kilometer per hour, right? They don't write the unit because it's already understood that is 40 kilometer per hour. It's not 40 centimeter per hour. That way the car will be like take ages to move, right? So these are, now why speed is a derived physical quantity? Because if you see the definition of a speed, the definition of a speed is distance covered per unit of time, right? So what is distance? Distance is a fundamental quantity, right? You measure distance with the unit of meters or kilometer.
You can also measure distance with distance equals speed times time.
Distance equals to speed times time. Yeah, you can play around with this formula. Now time is also a fundamental physical quantity because time is also measured in second. You don't need any other physical quantity to define distance, do you? No, right? So that's one definition of a fundamental physical quantity. Now, so this is depending on the nature of physical quantity, right? So let me write it down here. So this definition is dependent on the origin. You don't just say origin, right? Now, depending on the type of laws it follows or the properties, there are three types of physical quantity, out of which you need to know two. And what are those physical quantities?
Scalar.
Right, you already know that those physical quantities could be a scalar and vectors. Scalars and vectors, right? So scalars are those physical quantity which follow the rules of algebra, right? And vectors are those physical quantity which follows
Geometry.
the rules of geometry, right? So geometric rule or vectors rule, इसको और भी क्या बोल सकते हैं हम? We can call geometric rules or vector rules, right? Right, so this is the preamble of mechanics or classical mechanics which we are going to understand, right? You should have this genesis in your mind that you have got numbers, then you have got numbers with a unit, then you have got numbers with a unit and direction, right? So depending on whether the property of direction is following the laws of geometry or not, if it follows, it will be a vector physical quantity. If it doesn't, it will be a scalar physical quantity. Plus, when it comes to defining physical quantity in terms of its origin, you may have fundamental physical quantity, which are the physical quantity which require no other physical quantity to define it, right? So you don't need any other physical quantity to define length. You just need a ruler with a defined standard, right? Then you have got certain physical quantity like speed, velocity, acceleration, force, momentum, impulse. Those are the physical quantity which require help of some other physical quantity, right? So they are derived, right? So the name also implies it is derived from somewhere. Derived from where? is always derived from fundamental, right? Okay, good. Now we move on the discussion of vectors, where we started our geometrical properties and all, right? So vectors, when we say vectors, it automatically means a vector physical quantity. Sorry, vector physical quantity. A non-physical quantity cannot be defined as vector, because we don't have any such non-physical quantity which obeys geometrical laws, right? How we denote a vector, how we show a vector, right? We are dealing with empirical science, so everything which we talk should have some image, right? Should have some figure to talk to. So a vector is defined with an arrow, and a vector is named with some English letters, right? So this vector is called vector AB. It has got certain value which is written like this, mod AB, and then you have got a direction, n cap. Okay, is this understood? Is this understood? Now other way of writing a vector could be in some interesting ways. So if this is a displacement, imagine a person who is moving from this place to this place, then you can write vector AB as, if this length is, let's say, 5 meter, so how you will write it as
mod
5 meter east, right? But in physics, because we are going to use geometry in doing the calculations of which involve vectors, so we have to find a way which is more mathematical, or the way which will help you in doing mathematical operation. So that's why we define this unit vector in some real way, or in some interesting way, you can say. So for the known direction of north, south, east and west, unit vectors are I cap and j cap. And conversely, this is minus j cap and minus I cap, right? So n cap for east equals to I cap, and n cap for north j cap, right? The other thing which I explained last time is that if you have a vector which is in random direction, it's in a random direction, right? Now the way we will define its direction
is by the angle theta.
Yeah, is by the angle which is made with one of the 4 known directions. So the 4 known directions are north, south, east and west, right? So what we have to draw? We have to draw a Cartesian coordinate system. This is a Cartesian coordinate system.
Yep.
And put the vector, if this is a vector AB, we have to put this vector in this coordinate system AB, right? Now it's up to you that which angle you want to consider. So if you consider this angle theta, so you will say that this vector is at angle theta of east, right? Of, the word of will be with the direction from where the angle is being considered, right?
Yep.
Or you can have this angle alpha, which is alpha is equals to what? 90 minus theta. You can also say that this vector is towards east of north with this angle.
Okay.
or you can say that this vector is towards north of east with angle theta. समझ में आ रहा है? Right? Now if this vector is AB, so yesterday we did an exercise where we saw that this equals to, if the length of this vector is, let's suppose the length of this vector is d, right? The length. So you can write this as d of cos theta I cap plus d of
Sin theta.
sin theta j cap. So this is the formula you should know. Clear? Now what we are going to do is today is we are going to add two vectors. We are going to add two vectors. So let's suppose this is a vector AB and this is a vector CD. So there are two ways of adding the vector. One way is